Welcome to a code report algorithm video. In this video, we're going to be covering two algorithms from the STL numeric library, stdAccumulate and stdreduce. For stdAccumulate, we have an algorithm with linear time complexity that returns the result of accumulating all the values in the range first to last plus init. The default operation is to add the elements up, but a different operation can be specified as binary op. And here we have our function declaration. Accumulate that takes three parameters, two input iterators first and last, and the initial value in it. But there are several other overloads of this method, and they include the binary op mentioned here. For stdreduce, we have an algorithm with linear time complexity that reduces the range first to last, possibly permuted and aggregated in an unspecified manner, along with the initial value in it over binary op. The default operation, once again, is to add up the elements, but a different operation can be specified. And once again, we have our algorithm declaration here with the same parameters, but as mentioned before, we have a few overloads where we can specify a custom binary operator to do sort of a different operation. And note that in the definition of this algorithm, it says here, possibly permuted and aggregated in an unspecified manner. That's due to the fact that this is a parallel algorithm. And due to that, we have to have a binary operation in the form of a lambda or a function object, or just a higher order function in general that is commutative and associative, which means that you can, for the commutative property, you can sort of group the elements in any fashion and you still end up with the same result. And for the associative, you can sort of rearrange the elements. So when grouping, you can think of sort of adding parentheses here and there. And for rearranging, it's just changing the order. So addition is an operation, a binary operation that satisfies these two properties, but subtraction is one that does not. So that's just something to keep in mind, that there are a few restrictions when using stdreduce versus stdAccumulate. So if we go to the examples, we can see here, this is a C++ 17 example. Note that we don't have our template type explicitly declared here, and that's because we're using C++ 17's CTAD, class template argument deduction. We just have a vector of integers v 1, 2, 3, 4, and we have two different calls to accumulate here. One without a binary operator specified, and one with a binary operator specified. So for the first one, we're just going to be adding up the numbers, and our initial value is going to be 0. Note that when using auto with accumulate, the type that is deduced or inferred is based on the third parameter here, the type of init. So because 0 and 1 are integers, x and y are going to be type inferred to be integers. And so for x, we're going to end up with 10 because that's the sum of 0 and 1, 2, 3, 4. And for y, we're going to end up with 24 because we're going to end up with the product of the elements in our vector v. And note that these sort of act as the identity values of our operations here. So by default, we're summing up, and when summing, the identity value that we usually want is 0. But when we're multiplying, the identity value that we usually want is 1, because if we start with 0, we're just going to 0 everything out, obviously. So that's something to keep in mind when using accumulate to calculate using different types of operations. And you can get this multiplies from the functional STL library. If we take a look at reduce, it's very similar, but we have a couple differences. Obviously the name, note that when you don't specify a binary operator, you don't actually need to specify an initial value. And what the algorithm will do in this case is it will just use the first element in the data structure that you have passed to. So in this case, it will use 1 as the first element, and you're going to end up with x being equal to 10, y being equal to 10, because these are essentially equivalent, and z will once again be equal to 24. And a small note here, instead in C++ 17, instead of using the angle brackets and parentheses, you can actually use braces, so reduce your code by 2 characters here. If we go to the Wikipedia page for fold, which it says here is a higher order function, it says on the first line basically that it's also known as reduce, accumulate, aggregate, compress, or inject. So this is just something to keep in mind when going from language to language. So in C++ 11, we have accumulate. Now in C++ 17, we have reduce. But in other languages, I believe in C#, it's referred to as aggregate, and in D and Rust, it's referred to fold, and I believe on the next couple slides I show here. So you can see Rust, we have fold, and the initial value is the value the accumulator will have on the first call. So you can see here that it takes a init as well. But for D, we actually have two versions of the function. So the first version takes two parameters. One of them is the initial value, but there's also a one argument version that only takes the range and doesn't take an initial value, in which case it uses the first element of the range as the initial value. And we have fold and reduce here. So it's just good to keep in mind that accumulate, as it was named in C++ 11, is really the same as reduce and fold and aggregate and all these other functions. And I would recommend using C++ 17's reduce, as it is a better name, especially when you are providing a custom binary operator and sort of changing the semantic meaning of what you are doing with the accumulate. It leads to more readable code. And something to note is that a lot of the algorithms in the STL algorithm library can be implemented using a stdreduce or stdaccumulate. So one of the examples here is count. When you think about what you're doing in the count algorithm, you're just going through in a single pass and returning a single number, which is essentially what a reduce does. It goes through in a single pass and you sort of reduce a data structure into a single return type. And so these are both going to output the value 2 because there are two ones. And if we look at our implementation of my count, you can see here we're passing in two input iterators, F and L for first and last, and then a value that we're sort of checking to see how many times it exists. And we are just passing a custom binary operator in the form of a lambda, a generic lambda. So note this is C++ 14 here due to the generic lambda. And we're capturing the value val and then just doing a plus to our accumulating count A whenever B is equal to our val here. So that's our first example, and I have a second example of any of. So you can think, once again, any of, it's doing a single pass through your data structure and returning either a true or a false, whether or not our predicate is sort of satisfied. So in this example, we have std any of looping through our vector v and checking, basically using this lambda here, whether any of our elements are equal to 3. And we have an implementation called my any of, and if we take a look at that, doing something very similar to count. Once again, we've got our two input iterators, F and L for first and last, and in this case, we have a predicate, which is going to test the condition that we're checking for in our data structure, and then once again we're capturing P, and we have our generic lambda here, which is just going to sort of logical or our value A for whatever our predicate returns on the element B that we're currently looking at. And we initialize this to false, so if at any point our predicate returns true, our whole algorithm will return true as well. So note that this is probably not a very good implementation of any of. My guess is that the actual implementation short circuits. So as soon as you get one predicate returning true, the algorithm's going to, cut out and just return that value. But mine does not do that. But this is just supposed to be illustrative of how many of the algorithms in the STL algorithm library can be implemented using reduce. So there's two more things to mention. One was sort of noted earlier, and that is that the stdreduce from C++ 17 is a parallel algorithm. So I'm not going to go into much detail. Maybe I'll do this in a future video. But in C++ 17, we introduce execution policies, which can get used with any of the parallel algorithms. And there's a really good blog post by Simon Brand from Microsoft, and he goes into sort of the differences between stdaccumulate and stdreduce, specifically mentioning the execution policies and detailing how to use them and what they are. And then also Bryce Lelbeck, who works at NVIDIA, he has a whole CPPCon talk talking about the execution model and the differences between the different execution policies. So definitely check those out. Links in the description down below. And the last thing to note is how to use. So we've got 3 compilers for C++, Visual Studio, aka MSVC, and Clang and GCC. Visual Studio has an implementation, so if you're using the C++ 17 flag, you have access to the parallel algorithms. Unfortunately, Clang and GCC currently do not. From what I've heard, they are in at the moment working on this. So depending when you're watching this video, maybe they have already released their parallel algorithm implementation, but currently, as of today, it is not released. So if you want, you can go to Compiler Explorer, and just to note that, because I'm sure when most of you are using Compiler Explorer, you're using either GCC or Clang, the flag's slightly different. So for GCC and Clang, it's -std equals C++17, but if you're using one of the MSVC compilers, you have to use -std :C++17. So just make sure to do that. Otherwise, it's going to seem like you don't have access to the parallel algorithms. As always, if you enjoyed this video and found it helpful, hit that like button. If you want to see more, make sure to hit that subscribe button. You can follow me on Twitter for reminders 30 minutes before contests start, and you can find all of the code shown in my videos on my GitHub page. Thanks for watching, and I'll see you in the next video.